Las Vegas trip. So yeah, it's hard to come back to that kind of, you have all that family and then now you're away from them, back in the loop again now. Yep, back in the loop. Hey, Danny, Grace, Jasmine, how are you doing? You're not doing so well, huh? Just same old stuff, huh? Hey, Chloe. Hey, Madeline. Good to see you guys. Well, here we are, 10:05. So remember, tomorrow's Win Day. Announcements will, check your email and announcements if you have questions. Hey, Danny, being social, are you? Good trip for you. Hey, Ken, good to see you. Ken, do you ever say hello? I'd like to see even, if you even know that I'm talking to you. So if you can, same way with Madeline, if you can say hello. Thomas, good to see you. All right, we got good morning. So I got to get today is the 31st. I have to get my Christmas lights off of the lawn today. Yeah, they are. They can be not very social. That's for sure, Danny. That's again, that might be why they like Odella because they don't have to be, right? So that kind of stuff. Hey, Chloe Mason, how are you? And let's see, who else did I not see? I think we got everybody. So anyway, win tomorrow. So you make sure that you get in there if you have any questions. Okay, so motion's classified as how fast, and we talked about speed and velocity this week. So velocity, remember, has a direction. So let's do our first velocity question here. Let's see if we can answer this, right? Start a poll, right? So example number 3, right? So let's type this in here. So let's do this together, right? So zeta is a horse going 60 meters south. So remember, the south means it's a velocity vector, right? And it does it in 5 seconds. Okay, so we take the 60 meters as my distance, right? And then we take the 5 seconds as our time, right? So then now to find velocity, we take the distance divided by the time, okay? A lot of times we say displacement. And velocity always has displacement because we have south, right? Right, so remember when you answer this question, 60 divided by 5, make sure you put south in there, right? So, and this is meters per second. What is 60 divided by 5? Good. Excellent. Thanks, Rachel. And she kept the south in there, or the S, all right? So that's the difference between speed and velocity. All right. Thanks, Danny. So meters per second is the units. Okay. Distance is meters. S is in time. So it's every meter. So you end up with 12 meters for every second. So that's how quickly that horse is traveling. Distance divided by time. So it's south, right? So if I just wanted to know the speed, okay, then I would just do 60 divided by 5 and get 5 meters per second. But because I want to have a direction in there, then we have velocity. Okay, so how many people are comfortable on this? Okay, A is um, you're good using this pyramid triangle. B, okay. And then C, not good. All right, so if you're not good at that, let me know. So A, B, or C on this. And please, again, like I said, it helps me drive the instruction. it tells me that I need to work on this some more. If you're voting, please, if you're not doing well, put down not good so that I can help those people that need the help, right? So today what we're going to do is when we do a breakout room, I'm going to use a different classroom. I'm going to use another big blue button. So I'm going to put that in the shared notes. So this way you can come and join if you want to, rather than being me having to assign you. Sure, Kendrick, we can, you mean, right, you don't have a class right after 11? You don't have a class right after 11. We can do it at 12 if that works better for you. But I do have a breakout room here, so. Yeah, that'd be good. That'd be great. I'll just do it in the, let me write myself a note. I'll do it in this hour. Okay, I'll just open up this big blue button, second hour big blue at 12. Well, okay, got it written down there. I put it on my computer so I know. Yeah, sure. All right, so let's look at the polling. All right, everybody says they're either good or they're okay with it. So that's great. If you guys don't have, if things aren't working well for you, let me know. Okay. You're planning a road trip to Cleveland to Columbus. Columbus is 150 miles southwest of Cleveland. If you average 50 miles per hour traveling, how long will it take you to get there? Okay, so if we do this one, all right, so let's do number 5. Number 5. All right, so let's try to do this together. So how long will it take? So that's a distance, a time problem, right? Okay, so covering that up. That means distance divided by speed. All right, so 50 miles an hour is my speed. That's going to go on the bottom of my division sign, 50 here, and 150 here, right? And this is a time problem, so we're going to end up with hours here. So how many hours, if I take 150 divided by 50, will you get? $150 divided by 50. There we go. Thanks, Chloe. Anybody else? There we go. Thomas, thank you. Chloe and Rachel, Danny, anybody else? 4 out of 15. You're welcome, Kendrick. So I've got Gabby. Thanks, Gabby, for getting in there. So should be 3 hours, right? 150 divided by 50 gives you 3 hours. All right. So, okay. So that's how we use that. So let me ask you this question, type response. Why do we use graphs? So why is it important to use, again, I can tell you it's important to use them because they are something that you get tested over. It's important to know how to use them. It's also good information, but why do they use graphs and not just give you numbers? Like I can just give you a bunch of numbers. Why is the graph important versus just numbers showing up? You give you a spreadsheet of numbers and that's what we can use. That's what graphs are, just numbers, right? What makes it good? So I have circle graphs, I have pie charts, I have bar graphs. Why are those good? Okay. Somebody said easier to understand. Okay. And to see, right? So, right. So they're easier to see, right? That might be one of the things. Okay. So, yeah, they are visual, right? They can put a bunch of information and you can see in a pie chart, like How many people are passing my class? This is how many people are passing. Pass, fail. Okay. So that was last marking period. So if I give you a circle with and cut it in the middle, that means only 50% of the people in the class passed. Okay, which is not good for me. I don't like that at all. Oops, I got a cough here. Let me get some water in me. All right, so we had 3 people who said they're more visual. Yeah, they do. They are. So let's do some review here. Okay. All right. So what is that circled? Is that the X, Y, or Z axis? X, Y, or Z, right? All right. Thank you, Grace and Chloe and Gabby. All right. So most of you said we got 7 out of 17. Most of you said that's the y-axis. That's correct. This is the y-axis, right? Y is always the vertical one. So what does this one become? Oops, where did I go? Did I put 2 slides in here? Oh, I see I did. I must have used more than one slide in here. That's what my problem is. All right, that was what going on. I was wondering that last hour. All right, so what was this one then? The time. Usually time is on the bottom, horizontal axis. What is this one called? What's this one called? What is this one called? X, Y, or Z? I think I hit this one too quickly. All right, yeah, the horizontal axis. So you think about the horizon, right? Horizon, you're looking at the sun rising. It's not been, I've been kind of depressed because I haven't seen much sun. So this is the horizon line, and that's the x-axis, x-axis. And then the z-axis is when we have 3, I got z-axis. And oh, I see somebody put y in there. That's right. I didn't hit that correctly. Yeah, so these are the x-axis. The x-axis is the one that, so this is the y and this is the x. And we always write our numbers as x and y, right? So this is how we do when we try to locate something. First number is the, so like if I put this point right here, I would put 20 for the x and 10 for the y. Okay, it's always x and y. All right, so what's the distance here on the y-axis? What's the distance on this one in the y-axis? We're just looking at that. Can I make that bigger? Yeah, I can I? A little bit. Get my screen out of the way there. So what is, yeah, there we go. Most of you guys have, if you're looking at the distance here of this coming right over here, dotted line over, should say 10, right? Okay. How about this one? What is the time on this one? So if we're looking at this, right, the time is going down, right? So the time is what? Yeah, and it says S for seconds. Very good. Guys are getting it. All right, so this is just kind of a review for most of this, right? So, but hopefully, all right. And then again, what is the distance right at the starting line here? Lots of poll questions today. So come Friday, we're going to have a drawing because there's a lot of poll questions today. Yeah, you guys got 0 meters, right? Okay, so we did this one already. Okay, so let me know if you understand, if slope, okay, we're going to be talking about slope. Have you heard it? Um, um, heard about it? Or that would be A, you've heard of slope before, that's a new a word that you've heard before, or B, it's unfamiliar to you. Unfamiliar, so it's never heard it before. Unfamiliar with slope. Okay, because I know that you guys have, some of you guys have really good math connections. You may be in algebra or geometry, and your iReady says that you passed the algebra and geometry. Some of you say that from your iReady that you are maybe 8th grade or below. So if you've heard about it, let me know about it. If you've not heard about it, let me know, because then that way I can get that a little bit more practice for some of the people that need that. Okay, so most of you guys have heard of the slope before. Okay, so this is one of the questions that you'll be confronted with on the tests, most likely next week. I don't think you're going to see it this week. Is the slope is something that we're talking about when we look at lines. Okay, we look at something that is basically steep, right? And we call this a rise, how far it goes up, but it's also going over at the same time, and they call that run. So maybe you've heard that, rise over run, and this is from left to right. It goes up from left to right. Okay, so when we're going to find the slope here, when we find the slope of this line, we find the speed of a distance time graph. So here we're going to use this if you've had, like I taught 8th grade math. So we did this in 8th grade math, and the y coordinate final, okay, so the y coordinate final is 10 right here. That's the F, that's what the F stands for, y final. Y initial, the initial point, if I look at the y axis here and here, this is 0. The x final, so the x final is the 20, and it starts off at 0, in x initial 0. So this point right here, so we're looking for the slope of this line here, and it's basically the kind of a right angle underneath this line. That's what we're talking about. So we use this formula. M is slope. It's y final, so 10 minus 0 divided by x final, which is 20 minus 0. Okay, so this is a divide sign, so we end up having 10 divided by 20, or we get 0.5 meters per second. Okay, so we end up getting the speed from the slope. Okay, we can also say the slope is 1/2, which means it goes up 1 and over 2. Up 1 and over 2. So again, this is something that some of you are familiar with, some of you are unfamiliar. We'll be talking about this more at length. Okay, so let's take a look at a graph here. I'm going to show you, where did my, okay. I'm going to show you what we call the moving man. Okay, the moving man is a PhET simulation. And this PhET simulation, let me clear this, and we'll put it on pause. Okay, so you can see this is a graph that we have talked about, right? Now, what's different about this has a negative part about it, but this is the graph we've been talking about here is and I can't draw on this, is it starts from 0 and it doesn't go into the negative. The y doesn't go into a negative, but we can do this on here. So here the man is at 0 meters. Let's move him to 0 meters. And as I move the man, you can see it starts to graph that. Okay, so let's start it. So if the man doesn't move, you can see the line is showing that he's at 0 meters and he's not moving. As I move the man, all right, little by little, I get this slope that goes from left to right, goes up from left to right. I stop, another flat spot. So we stop is a flat spot. Now when I back him up, I get a graph that goes in the opposite direction. So I go down from left to right. So up from left to right is moving forward, stopping, flat spot, going backwards. Okay, so this is what we look at when we're doing a moving man and plotting distance and over time. Okay, and that's what we end up doing. So if you look at the cheat sheet we have here, right, you'll see that upward trends from left to right, are moving forward. So if I have a graph here and I have a line like this or a line like that, that means it's moving forward. Now, depending on the steepness of the slope, means he's moving faster. So let's ask this question. All right, I'm going to ask you a question. I'm going to do a poll here. A horrible movie. That's cool. I like that. Oh, a horrible movie. All right. So of these questions here, so which of these will you think is faster? If that is moving faster? Is the moving faster on my graph, is it A or B moving faster? Okay, so let's take a look at this question here. So looking at my graph that I just drew in here, from left to right is A or B. So this is my y-axis and this is my x-axis. So don't get confused with that, all right? So try that one. What do you think? A is faster than B or B is faster than A? All right, so what do you think? Thanks, Rachel. Thanks, Gray. Thanks, Danny. Little brother is coming to need some pets here. So you guys are mostly saying, thanks, Dalton, letter B. Yeah, and you were correct. 6 of you out of 7 said B is faster. And if you look at the moving man, right? The horror movie that you guys are calling it, I like it. I like it. Really cool. Got a horror movie. So if I move the man really fast, wow, look at how fast. See how sharp that slope is, right? And I move him really slow backwards. Notice it's kind of gradual. It's like you're going downhill really not very fast at all. All right, so here we're going to go kind of, kind of slowly. You can see that I'm moving pretty constantly to the house, and that is not as steep from left to right, as if I'm going really fast, and then I get a really sharp. It's almost like it would be really hard to move forward, right? Okay, so here is constant speed, no motion. Remember, no motion looks like this, flat. All right, so I might have started and then I stopped. Stopped is flat. And this is going backwards. So negative slope from left to right, negative is going down, going backwards. Right, now this is a position and time graph. Okay, we will show you other graphs where we do speed versus time and changing speed, and these graphs make a difference. So the steeper the slope, the greater the speed. Now curve speed means that speed is changing. Okay, so this means it's changing, it's getting faster. All right. this letter A and B show constant speed. Constant speed, it means it's not speeding up or slowing down. This means it's speeding up. This is speeding up. And this means slowing down. All right, sorry, probably like this, slowing down. Let me just get this one down here. So this is slowing down. Okay, so let's take a look at this one. Let's do these questions before we get done here. All right, so thank you guys for your participation here. From the red to the blue, are we moving forward, no motion, or moving backward? And if it really does help if you guys can, I did start a poll. Okay, it really does help if you put your information. Oh, I know what I need to do. I got to give you A, B, or C. Let me publish a poll. Let me do this again. Start a poll, A, B, or C. There we go. Start a poll. There we go. A, B, or C. All right, which one is it? All right, so most of you are saying moving forward, and that makes sense. Here it says the upward trend, positive value, moving forward. So from left to right, it's going up. So that's moving forward. All right, one person said moving backward. Okay, so moving backward looks like a negative trend. Okay, so moving backward looks like, if I have my graph here, it looks like going that way, going from left to right, going down. Here it goes up, there it goes down. That's moving backward. All right, so let's take a look at the next one, blue to yellow. Okay, blue to yellow. What is blue to yellow? Is it moving forward, no motion, or moving backward? All right. Okay. So I got 5 out of 21. I got more people in here. Who haven't I said hello to? Oh, I didn't see Journey come in or Jasmine. All right. Good to see you. Natalia, I didn't see you either. Stephen, good to see you. All right. So this one is no motion. Okay. The blue to yellow is no motion. Remember, constant horizontal line, no motion. Remember, horizontal is when you see the sunrise, right? You see the sunrise, horizontal. Okay, horizontal. So that's no motion here. So a couple of you got that one right, right? So going up is forward, up, forward, forward, no motion. Going down, backward. Okay, so let's make sure that we understand each other here. Okay. All right, so how about from yellow to green? What is this one? Yellow to green. Yellow to green. Forward, backward, no motion. All right, got some people said. Thanks, Adriana. Oh yeah, you guys are getting it. Thanks, Gray. Rainy. No, Rainy. That's from first hour. Danny. All right, so 6 of you said, 7 and 9 of you said moving forward. Excellent. How about this last one? Green to black circle. Start a poll. Oops, not going to do that. Going to do this one. Start a poll. All right, how about this one? Green to black. All right, you guys got it. Moving backward. Okay. Right. Okay, so we're going to do this look at here just to practice you guys out here. All right, so let me do this one. Okay, so I've got more questions on this. You can participate with your friends here. Where are you, Mr. Blickett? Where are you? Okay. There we go. 11 questions. And you guys, I'm going to do crypto hack on you because we're running out of time. So let me do that. Guys are going to do, we're going to do crypto hack here. I'm going to give you 7 minutes. Excuse me. All right, so I'm going to give you 7 minutes for this because that way you get to see it. I'm going to play with you guys a little bit too. So I'm going to practice against you. All right, host now. Copy link. All right, there you go. You put this on pause. Good job, guys. Mr. Gale's in the last here. It's hard to read those things. Using my phone. I'm not sure if you guys are using your phone or not, but so okay. 7 seconds. Rachel, Greg, Gabby. Oh my gosh. All right. Final standing. Okay. So if you guys are interested in want to get working on your assignments here. Okay, so remember tomorrow's win day. W week 2 assignment 2 has the slope in there. Okay, so it has velocity in there, some calculations, a little tougher than the first one. If you didn't do week 2 assignment 1, that one you just use your notes on and you can do that one pretty well. There's no calculations in that. So you can get started on that. Okay. All right. And let's see if I have any questions here. So I'm going to open up a, good job, Gabby. I'm going to open up a breakout room, but it's going to be in different classrooms. So if you have questions, I'm going to put in the shared notes, I'm going to put the link to another classroom, and it's another big blue button link. So if you have questions about this, I'm not going to put people in breakout rooms because I'm going to allow you guys to ask questions about anything that we've been working on. All right. So if you have any questions, look for the link here. So all I ask is that when you come in, you have your name on that. Okay. So, all right. So you guys have 15 minutes to work on some assignments. So do that now. There's also bonus.